So this is day 2, part 2, and in the previous one we would pass a line and say that it has to have 1 to 3 A's in the password. Now we say that either position 1 or position 3 has to have an A in it. Okay, so it's basically exactly the same thing. We're just gonna, I mean, we should really rename it, but whatever. It shouldn't be min-max anymore. Should I make the whole password different? Should I just fix this one? Should it handle both? Should handle both. Okay, I'm just gonna put fn valid part 2 and self. It's a similar thing. We just go okay, so we're gonna, in part 2 of the, what do you call, whatever, in part 2, min and max actually become index 1 based index, A and B, and exactly one of those must hold the letter. Make it pretty. So we're gonna go, we can just do that. What happens if it's longer? Well, I guess we'll find out, right? It'll just crash the program. So we will say if self, we have to go literally that, self.password self.min plus 1, not 1 minus 1, because 1 means 0, equals self.letter, or self.password self.max minus 1 equals letter. I really hate having it have overflow of error problems right there. We could just say, look, if self.min is greater than letter.len, greater than or equal to, it's gonna be, if 1 means 0, then whatever, greater than len plus 1, wouldn't that be it? Or self.max is greater than letter.len plus 1, or self.min is less than 1, or self.max is less than 1. Return false. That code looks ugly. That's, the wrapping is not going to help. Looks a bit better, but still. That's going to be self.letter, not self.password. So we're checking for overflow errors here. Oh, you know what? I can just do get. There you go. So we can just. No, you can't, because strings don't have Unicode, which could be multiple characters long. But that still works somehow magically. Whatever. Okay. Let's just make it simple. No overflow checking. Done. If that equals a letter, so the password, so the min minus 1. Why is that got errors in it? The type string cannot be indexed by usize. Ah, that's interesting. So we have to go like self.password.cars.enumerate, which will give us dot. This will give us each car and their index, and then we can go filter. I'll call it I and C, the index and the car. I equals self dot min. Oh, you know what we can do is we can just map the I to be one character up. Yeah, dot map I C I plus 1 C, because then the 0 based index becomes 1. They're giving us letter 1. Now we're looking through the characters. We have enumerate, which gives us 0 is the first character. We want to turn it into 1 so that it matches what the parameters are. Yeah, that's nice. Okay. Then we only care about if 1 equals self.min or I equals self.max. Then we go find IC. We want to find we want to find both of them, don't we? We want to say if more than 1. We filter it again. We filter it again and we say if C equals, so we got the one that equals self.letter, then we care about it. Then we're going to go dot take 2, because we only care about the first one. That matches equals that. Okay, that's terrible coding. Let's go through it again. So we're going through the password, we're going through every character, we're adding an index to them, we're incrementing. The input is 1 based, but enumerate is 0 based. So add 1 to make I match the input. Okay. Why is it got a little squiggle there? Anyway, who cares? Next. Then we're okay. Only show us the characters and the indexes we care about. If they match self.letter, collect it. If more than 1 matches, it's a fail. So we'll just put .collect here and we'll turn it into a vec. Why not? No, we don't even need to. We just go to .count. Let match count equals that, and then the answer is it valid? Is count equals 1. Anything else, it's a fail. If it's 0, it's a fail. If it's 2 or more, it's a fail. I mean, if it, yeah, it's got to be 1. I think that's good. Let's see what errors we got. Not found in the scope. We'll just call it count instead of match count. It's okay. Okay, so we know what we're doing. In part 2, min-max. Okay, anyway. No implementation for usize equals usize. Easy one to fix. We just put an ampersand there, and same here. And then same. You know why it's complaining? Because we don't use the index here. That's okay. So here we don't use the car, so we just got that. And here we don't use the I, so we just replace it with that. It's trying to be nice and tell us, did you forget to do something? And looks better. No. Expected use size found reference. Why can't I unreference it? Whatever, I'll just put a star here and do it that way. And same here, expected car found reference. Okay, so same thing here. Ooh, it ran. So now we've got to go part 2. Why did it have a warning? Because that code's never used. Of course not, because we haven't used it yet. Okay. I've got passwords already, so we go let word count again equals passwords dot. We didn't change them anyway. No, we didn't. Good. Iter dot filter password dot. What do we call it? Part 2. Valid part 2. So we only care about those. Dot count. And there we go. Part 2. There are so many valid passwords. I just want to make pretty comments. Okay, save. Run. So part 2 of the 335. I want to go over my code again. It's hard to explain it. So this is okay. In part 1, this is the minimum number of occurrences for letter. Minimum becomes maximum. We should just create a new struct, really. Password part 1, password part 2. This is the first index to look for letter. Second index, look for letter. This is the letter used to validate the password. Like if I came back to this in a year and tried to read it, that's what we will be validating. Okay, this is part. This is only for part 1. In fact, why don't we just rename it with the old refactor tool here? Okay, let me just put here. Whatever. I'll just valid part 1. There. Another way of renaming it. In part 2, min and max actually become index. One base index. Indexes of A and B. They must hold the letter. So we go get the string, enumerate through the. So we're listing the give each character an index. Go through all the characters. And the reason we can't do that is because they're Unicode and some could be 2 bytes in Rust. So you have to iterate. You can't just index. Only show the characters. Input is 1 base, but enumerate 0 base to add 1 to make I match the input. Only show the characters at the indexes we care about if they match the letter collected. So here we're going. We only care about I, and if it's salt.min or salt.max, then we care about it, and then care about the letter if it matches. We only care about 1 or more. 1 matches, 2 matches or more is bad. Okay, and count has to be 1. That's nice. I like it. See, 1 of those must hold letters. That's why we do. Okay. Run again. Okay, 335. Let's see if it works. 335. Submit. Yay.